All right, so we're going to take a look now at the next box here on the page to try to summarize everything we just did in the last video. So we said in the last video, or we saw in the last video, how we could actually go ahead and construct one of these confidence intervals. And here's the summary. A C% confidence interval for a population proportion P. This is an interval that I make to find a mystery percentage. Well, it could be given by the following notation. This is some really weird notation, but you'll notice that it has a very similar rhythm to what we've always done when we've built intervals in this class. We say that we have something in the middle. This is our p hat. This is in the center of the interval. And what we're going to do is we're going to add or subtract something to that. We're going to go up a little bit and down a little bit. And what we go up or down by is our margin of error. That's what this stuff is over here, which is identical to what's being added and subtracted there. What you'll notice is that what we kind of have listed in here is something very similar to the standard deviation of the p hat values. And so we're kind of creating one of those standard deviation sort of intervals that we've made when we did standard deviation interpretations. Okay. This weird value of ZC is just some special scaling value that helps us to determine how many standard deviations we're supposed to jump up and down in order to create our interval. We won't ever have to find that value on our own. We just need to know the little value of C, which remember stands for our level of confidence. The calculator will take care of the rest of the work. Okay. So over here we have some necessary checks. We must first check to see if the sampling distribution of p hat can be approximated by a normal distribution, just like we did in the example previously. So of course, then it's no surprise that we have these associated checks. Okay? I'm going to jump right down here to example number 1. And surprise, surprise, it's exactly the same as what we were working on before. This time, though, I'm just going to show you how you can use the calculator to immediately arrive at this answer. Okay, so I still have the news organization making this claim. I want to construct and interpret a 90% confidence interval for the overall proportion of voters who prefer candidate X. Okay, so notice I'm told that I want to build an interval. I want to interpret what it means. I'm told the level of confidence, and I'm told that it's for this particular value. I want to figure out where is this mystery percentage of people that vote for the candidate. So some of the first things I write down are some of my given pieces of information here. Now, some of this we've already seen. Like we know that we asked, or there were 424 people that said they would vote for the candidate, and that was out of 800. We know that that gives us a p hat value, 424 out of 800. We already computed that as 0.53. Okay. So if we were to go ahead then and take a look at the appropriate checks that we need to perform, we'll see that actually all of this information is listed in the formula sheet, so I don't have to remember. If you take a look at the formula sheet over here, you'll see that on the left side, I have our conditions laid out. I say that we have these 2 checks to make, and here's all the information that I need in order to be able to have the calculator build this interval. This is why I wrote down originally what the value of p hat was and what the value of x and n were, so I could find these. The last thing I'll write is that C value for my level of confidence. Let me go ahead and add that in here. I see that my C is 0.90, 90%. All right, when I run my checks, I'm not actually going to go ahead and recheck them here because we already did this up above. So already completed above. You can go back and take a look where we actually did those. We know that both those things actually do check off. So let me show you how I could use the calculator to actually build the interval here. And once I've built the interval, I will try to interpret it. Now, we should already know what the interval is because we computed it in the last video. But now we should be able to confirm that the calculator can get us the same thing. Okay, so here's what I would do if I wanted to go ahead and actually build this interval with the calculator. I would start by clicking on the Stat button. I would go over to Tests, where we normally did stuff like our 1 proportion Z test and our T test that we did in Chapter 7. But this time, I want to do something that states a 1 prop Z interval. Again, you don't have to memorize that because that is written on your formula sheet. It's a 1 prop z int. Notice it's different than the 1 prop z test. So we want to make sure we're looking for the right thing. So for me, this option is a little bit far down on the calculator. I think I have it somewhere around my number or letter A. So when I click on this, you'll notice that it asks me for all the information that I've already written down. There were 424 people out of 800, and I want a confidence level of 90%. You got to remember to put in that confidence level as a decimal, or the calculator will give you an error. Once I hit the calculate button, it should automatically go through and boom, compute an interval. And we're going to do the same thing we always do, which is round our decimals to 4 places. So let me go ahead and pull that up here and round to 4 places. So 5, 0 looks like 1, 0 because the 8 rounds up into the 9. And then the second value would be 0.5590. There we go. So I have my interval now constructed. What you'll notice is that's the exact same interval that we actually had all the way up here. Nothing's different, but notice the calculator did that in just the snap of a finger. So the last thing that we would need to do here is to interpret what exactly this means. And I'm going to ask you to interpret pretty much every single interval that we come across in this class. It is your job to make sure that you understand how to interpret and what it is that you found here. It does no good to tell me just what the interval is. On questions like this on works or exams, most of the points are going to be associated with the interpretation. And the interpretation is so easy and so formulaic. Here's what it would sound like. We could state that we are kind of some percent confident that the actual percentage of all voters who will vote for candidate X, right? That's what we're looking for. We're looking for the actual percentage of all voters, not these 800, but of all voters who will vote for candidate X. And we are confident that that percentage is between, let's see, that would be 50.10% and 55.9%. Now, of course, I've left a little blank in here, which is associated with how confident actually am I that right now I'm holding one of the green intervals, like we saw in the simulation in the last video. Well, remember exactly what my level of confidence is for. I should now be 90% confident that the real value of P is actually inside of my interval. I can't guarantee that it's in there, but I'm pretty confident that it's there. All right. If you take a look down at the next page, you'll see that there's a couple other parts that I go ahead and start to talk through here. Some other basic things I should be able to do. Part B, can I identify the margin of error for the confidence interval? Remember, that should actually be super, super easy to compute because if I think about how my interval is made, I know that I had my 2 endpoints, and those were at my 0.5010 and 0.5590. That was the interval that I constructed. I can see it up above. And in the middle of that interval, remember, was the value p hat. That was our starting guess. And our p hat was 0.53. Do you remember how we said we would find, or what we called, the margin of error? Well, yeah, remember the margin of error was just how far did you go from the middle to the edge. And that's super easy to find here because that margin of error is just that simple distance. So I could just do the 0.5590 minus the 0.53. That would tell me this red distance in the picture. So when I crunch that, I think I'm going to end up with a value like 0.029. So the margin of error is it looks like that would simplify to 2.9%. So like my best guess is 53, but I could be wrong. So I'm going to go up 2.9%, down 2.9%. Okay, so part B is supposed to be an easy question. And we could always imagine constructing it that way. Notice that you don't have to actually go ahead and use this upper endpoint if you don't want to. You could find the same distance by doing 0.53 and subtracting the lower bound. Doesn't matter. Now, parts C and D oftentimes appear to be like they're very tricky questions, but they're not supposed to be tricky questions at all. Take a look here at part C. Suppose that the true overall percentage of voters who prefer candidates is exactly 60%. So notice they're saying like the overall proportion of voters is exactly 60. Like pretend the value is exactly 60. Well, then we know that some of the intervals that we could ever make when we ask samples of 800 people are going to be good, and some intervals are going to be bad. But the question would be, what percentage of samples of size 800 would make a 90% confidence interval that contains 60%? That is, what percentage of the 90% confidence intervals will be good ones? Wasn't that exactly what we talked about in the simulation? That if I create 90% confidence intervals, and I'll just adjust this value down. If I create 90% confidence intervals, then it's 90%. So this question here requires pretty much no work. 90% of 90% confidence intervals are good, which means, of course, that 10% of those types of intervals are bad. This is actually one of the easiest questions on the test, I do ask questions like this on the test fairly frequently. But in this particular problem here, this is a very, very easy question. Take a look at part D. This one's even easier. Does the confidence interval that we constructed up above, right? I mean, we can see it here in part B. It goes from 0.5010 to 0.5590. Does the confidence interval actually cover the value of the population proportion of voters who prefer candidate X? So that is the real value of P inside our interval, yes or no? That's kind of a really tough question to answer because right now, suppose we put it in current terms. Donald Trump is obviously going to run for re-election for the presidency. Right now, I'd like you to tell me what percentage of all Americans are going to vote for him in the upcoming election. Go. I want the exact value. But none of us know that value. How could any of us know that value until election day hits? We don't know that number. So even though I might take guesses as to what that number is, and I might build a confidence interval, I have no idea what the value is actually going to be. So it seems kind of strange here because this almost sets itself up as an easy yes-no question, but there's also a hidden third option, which is, I don't know. And surprisingly, for the first time ever in a math class, this is the right answer. Does the interval cover the real value? I don't know. I'm 90% confident that it does, but I'm also 10% confident that it doesn't. So I don't really know for sure. I'm going to bet money that it does, but I can't be 100% guaranteeing anything. Okay. Well, that wraps up this particular video. In the next one, we'll take a look here at example 2.